Welcome class 9. Today we will learn the numericals on graphical representation of linear motion. So here we discuss or we'll learn about the numericals which has been given in the book as an example. So question number 1 from the book, which says the following table represents the distance of a car at different instants in a fixed direction. So the table is given, and number A, draw displacement time graph and with its help find whether the motion of car is uniform or non-uniform. Number B, use graph to calculate the velocity of car, the displacement of car at t equals 2.5 second and t equals 4.5 second. So let's try to understand. So firstly, as the question reads, the following table represents the distance of a car at different instants. So here the table is given. So this means that with the help of this table, we can draw the graph. So the displacement time graph for the car is shown out here. Since it is a straight line OA inclined with the time axis, so the motion of car is with uniform velocity. So let's have a look at the graph. So here time is in the x-axis, displacement on the y-axis. Time has been divided in terms of 1, 2, 3, 4, 5 and so on, because here in the table we can see that time is divided as 0, 1, 2, 3, 4, 5. So according to that it has been divided. All right. Then distance in terms of meter, it is 0, 10, 20, 30, 40, 50. So it has been marked as 0, 10, 20, 30, 40 and 50. Now according to the first data, it is 0 with 0. So 0 with 0 is this point. Next it is 1 with 10. So 1 and 10, which is coming out over here at this point. So this point is marked. Then it is 2 and 20. So 2 on x-axis and 20 on y-axis. So 2 and 20. Similarly, the next one is 3 and 30, 4 and 40 and 5 and 50. So when these points are plotted on the graph paper and if they are connected, then a straight line which is represented by a red line out here is formed. So this is the graph of displacement time. So this is the displacement time graph. So this is actually the graph which has been which is required out here, and this table, the data given in the table will help us to find out the graph which is represented by a red line out here. So now part A is done, drawing the graph. Number B, use graph to calculate. Now we have to calculate the velocity of the car using the graph. So now the velocity of the car, we know its velocity is represented by the slope of the line. So slope of the straight line over here OA, as we have learned earlier, it is represented by the perpendicular divided by the base. Okay, so the perpendicular over here is AB. All right, so AB or BA, so which is equal to this 50 minus 0, that is this line is 50. Okay, 50 meters, and OB is the time, that is equal to 5 minus 0, that is 5 seconds. So 50 divided by 5 is equal to 10 meters per second. That becomes the answer or the velocity of the car. Now we have to find the displacement of the car at t equals 2.5 seconds. So when time is taken as 2.5 seconds, we'll take the mark of 2.5 seconds out here from the graph, and we'll produce the line and meet this graph over here. And from here we'll take the line which which falls on the same point on the y-axis. So on the y-axis, that is on the displacement axis, it reaches the point 25. Okay, this means that when time is 2.5 seconds, the displacement that takes place is 25 meters. All right, And similarly, when time t is equal to 4.5 seconds, the displacement equivalent is 45 meters. So 25 meters and 45 meters becomes the required answer. Next is question number 3, which reads, a car travels with a uniform velocity of 20 meters per second for 5 seconds. The brakes are then applied and the car is uniformly retarded. It comes to rest in further 8 seconds. Draw a graph of velocity against time and use this graph to find these questions. I'll read later. So let's focus on the first part of the question. So there's a car which travels with a uniform velocity of 20 meters per second for 5 seconds. So the graph required over here is like, the time is taken on the x-axis, and from 0 we'll start marking it, okay, and we'll produce it up till 13. Over here it has been marked. We can produce it up till 15. So 0 1 2 3 4 up till 15 we can mark. And similarly over here, we'll take the marks of on the velocity, that is velocity which is plotted on the y-axis. Okay, that is taken as 5 meters per second as 1 unit each. So 5 meters per second, then another 5, that is 10, then 15, 20, 30, and so on. So here the first sentence as it reads, a car travels with a uniform velocity of 20 meters per second for 5 seconds. So for 5 seconds, from here to here, for 5 seconds, it travels with the speed, or we can say the velocity, of 20 meters per second. So it remains 20 meters per second up till 5 seconds. Okay, from this point to this point, for 5 seconds it remains fixed at 20 meters per second. That means this line is going to be parallel. It will not increase because it's not increasing, the velocity is not increasing, it remains fixed at 20 meters per second. So for uniform velocity, as we have learned, the line is going to be fixed and it will be parallel to x-axis. So up till the 5 seconds, the line over here, which is represented by AB, becomes parallel to x-axis. Then it comes to rest in further 8 seconds. So from here, further 8 seconds means 1, 2, 3, 4, 5, 6, 7, 8. So further 8 seconds, the brakes are applied and it comes to rest in further 8 seconds. So from here, the speed will decrease because it is going to come to rest at 8 seconds, after 8 seconds. So here the retardation is shown by this inclined line, which is inclined in a negative way. Okay, so it's not inclined positively, it is inclined negatively, and it comes to rest at point 13. That means after 8 seconds it is going to stop. So draw a graph of velocity against time using use this graph to find all these questions. So over here, this is the required graph. All right, now let's focus on the second part. The distance traveled in first 5 seconds means this distance at from 0 to 5 seconds. What is the distance traveled? And since displacement or distance is equal to velocity times velocity into time, so here velocity into time will give the area of this portion. Okay, area of this rectangle formed by ABDO. So the distance traveled in first 5 seconds equals to area of rectangle OABD. So OABD is the rectangle, which is equal to OD into OA. So OD into OA. OD is 5 seconds, OA is 20 meters per second, which multiplies and gives the answer 100 meter. So first case, the displacement is equal to 100 meters. Next, we have to find the distance traveled after the brakes are applied. So what is the distance that moves, that the car moves after applying the brakes? So how much distance is covered? So in the second case, the distance traveled by the car after the brakes are applied is this triangle. Okay, so this triangle, the formula for the area of the triangle is equal to half base into height. So half base is DC and height is BD. So half into DC is this much from here to here, that is 13 minus 5, okay, 13 minus 5 seconds, and BD again, BD is equal to 20 meters per second. So this on further simplification, it gives us answer 80 meters. So this is the distance traveled after the brakes are applied by the car. Thirdly, we have to find the total distance traveled. So number 3, the total distance traveled is equal to area of rectangle OABD plus area of triangle BDC. So the total distance will be this area plus this area, that is the area of the rectangle plus the area of the triangle, which is equal to 100 plus 80, that is 180 meters. So 180 meters is the total distance traveled by the car. And fourthly, we have to find the acceleration during the first 5 seconds and the last 8 seconds. So in the first 5 seconds, as we can see, the speed is constant or the velocity is constant or uniform. There is no acceleration. So firstly, acceleration in the first 5 seconds is 0 because there is no acceleration, or we can say the velocity is uniform. Okay. And acceleration in the last 8 seconds out here in this portion, in 8 seconds the acceleration is negative because here we can see it is negatively inclined. Okay, so the slope of this line will give us the acceleration. Okay, over here the slope is equal to BD by DC. Okay, BD, we can take the length positive, but since it is negatively inclined, so we'll put a minus sign over here. So 20 meters per second is the distance BD. Okay, so BD, and it is negative, so minus sign, and 13 minus 5, that is from this point to this point, this 13 minus 5, which is equal to 8 seconds. And when you simplify this one, you'll get minus 2.5 meters per second squared. This means it is acceleration in negative, or we can say simply it's the retardation of 2.5 meters per second squared. Next is question number 6. A car starting from rest accelerates at a rate of 2 meters per second square for 5 seconds. For this journey, draw the velocity time graph, draw the displacement time graph using the velocity time graph in part A. So here, since a car starts from rest, its u, initial velocity, is equal to 0, and its acceleration is 2 meters per second squared. Alright. Now, for this journey, we have to draw the velocity time graph. So when it is 0, time is 0, there is no acceleration since the initial velocity is also 0, and there is no speed, there is no initial velocity, so velocity will remain 0. But as time increases to 1 second, now since there is an acceleration of 2 meters per second square, so per second there is an increase of velocity by 2 meters. So the velocity becomes 2 meters per second. Then time increases to 2 seconds. Then again 2 meters per second the velocity will increase. So here it becomes 4. So when it reaches 3 seconds, the velocity becomes 6 meters per second. When it is 4 seconds, then it becomes 8 meters per second, and for 5 seconds it becomes 10 meters per second. So every second the velocity increases by 2 meters per second, as we can see out here in the table. So using this table, we'll plot the graph. On x-axis we take 0, 1, 2, 3, 4, 5 as it is in the reading, and over here 0, 2, 4, 6, 8, 10, there's a every time it's the skip of two values. Okay, so 0, 2, 4, 6, 8 and 10. So this, when we plot 0, 0, then 1 comma 2, 2 comma 4 and 3 comma 6, then it's 4 comma 8, 4 comma 8 and 5 comma 10. And when this is plotted, okay, this is the graph that is obtained. So the graph over here is the velocity time graph as asked in the question part A. Now we have to draw the displacement time graph from this one. So from here, from this graph, we can see the displacement of the car at any instant can be obtained by finding the area enclosed by the straight line with the time axis up to that instant. That means here how much is the displacement. So we can calculate this area of this triangle over here, 0 1 and this point. Okay, so if you take the area of this triangle, small triangle formed, then we can find out the displacement. So at time 1 second, when it is time 1 second, the displacement is equal to area of this triangle, that is half base into height. So half of base, that is 1 second, into height 2, half of 1 into 2, 2 and 2 cancels, you'll get 1 meter as the displacement. In the second case, when it is 2 second, that means this triangle from here to here, this triangle, okay, half base into height, so half into 2 seconds into the height is 4, okay, here you'll get 4 meter as the displacement. Similarly, if you keep on calculating, you'll get 9 meters, 16 meters and 25 meters respectively. So the graph table that we'll get is displacement time. For the displacement time graph, you'll get 0 for 0, okay, 0 comma 0. Then for 1 second time, the displacement is 1 meter. For 2 second time, the displacement is 4 meter. For the displacement of 3, for the time second, for the time of 3 seconds, the displacement is 9. Then for 4 seconds, 16. 5 seconds, it is 25. So every time you will see the square is formed. Okay, 0 0 1 1, square of 2 is 4, square of 3 is 9, square of 4 is 16 and square of 5 is 25. So when you plot this kind of graph, you will get this kind of curve as a graph. Okay, so this is the displacement time graph for this particular situation. Next is question number 1 from the exercise. So here this figure 2.37 shows the displacement time graph for the motion of a body. So here is the graph which represents the motion of a body, and use it to calculate the velocity of a body at time 1 second, 2 second, 3 second, and then draw the velocity time graph for it in figure B. That means using this graph, we have to calculate the velocity and we have to plot the graph out here. So when it is 1 second, okay, the displacement is 2 meters. So we can say when time is 1 second, the displacement is 2 meters. Out here we can see from this figure. So the speed or velocity is equal to speed by time. So that is equal to 2 meters divided by 1 second. It is equal to 2 meters per second. In the next case, when the time is 2 seconds, okay, the displacement is 4. So when time is 2 seconds, the displacement is 4. Therefore, the velocity is equal to 4 meters divided by 2. That is again 2 meters per second. When the time is 3 seconds, we can see in the graph, time 3 seconds, then the displacement is 6. So velocity is equal to 6 divided by 3, again 2 meters per second. And when time is 4 second, out here 4 second, then the displacement is 8 meters. So velocity again is 8 divided by 4, again 2 meters per second. So in every case we are seeing that the speed is uniform or the velocity is uniform. So for the uniform velocity, since velocity is constant, so here when time is 1 second, for this case, okay, when time is 1 second, the velocity is 2 meters per second only. When time is 2 seconds, the velocity remains 2 meters per second itself. And when time is 3 seconds, the velocity remains 2 meters per second only. So it's not going to increase, neither it's going to decrease. Therefore, the required graph will be over here. When time is 1 second, the speed remains 2, 2, 2, 2, and it remains fixed. So when you plot the graph at these points, you'll get a straight line like this. and this will be the straight line or the graph, okay, uh, for the constant velocity or the uniform velocity in this case.